Hi, I'm back again with a video on Le Chatelier's principle. This is a concept coming up in chemical equilibrium chapter. So in this video, we are going to see what is Le Chatelier's principle. Because before jumping into the real concept of Le Chatelier's principle, let's try to understand it based on a real life situation. So here you can see a pendulum. It has been hanged from a rod that is placed horizontally. Now, when I'm moving the pendulum to one side and release it, what will you observe? You will see that the pendulum goes for to and fro oscillations. After several to and fro oscillations, the oscillations will die out gradually and the pendulum will come to an resting position. Now, the resting position is going to be 0. This is going to be the mean position, or this is going to be the equilibrium position. That is the reason why the pendulum after several oscillations will be coming to a rest to this particular point. Now, assume that I am giving a disturbance to it. Now, when I say disturbance, this is what I mean. I'll be tilting the angle of inclination of this particular rod. So what happens? Do you think this time also the pendulum will come to rest at 0? Never. This time, after several oscillations, it will be finding a new resting position or a new equilibrium position, and that will be somewhere here. So what is happening? When I am giving a disturbance to the equilibrium, this pendulum is responding back so that it is getting back its equilibrium. What is happening? When I disturb a system at equilibrium, it is responding back because it wants to regain the equilibrium which it was having. Now, in order to understand this, we will try to we will see another situation. Here you can see a spring with a weight at the bottom. When I'm pulling the weight downwards and release it, this spring also will have oscillations, but after several oscillations, it will be coming to an equilibrium or a resting position like this, wherein the spacing between the spirals of the spring will be slightly increased when compared to the spacing in its absence. I'll explain to you with a diagram. There are three situations. One, there is no weight. Here you are having a small weight. Here you are having higher weight. When there is no weight, you can see that the spring is achieving an equilibrium position with minimum spacing between the spirals. And depending upon the weight what I am hanging on it, the spring is definitely attaining an equilibrium position, but depending upon the weight what is being added, the equilibrium, the spacing between the spirals in the equilibrium position is changing. That is what this principle is all about. When a disturbance is caused to a system at equilibrium, it will respond to get back its equilibrium. Now, let's try to understand this concept. Now, let's try to apply it in chemical reactions. So, before proceeding to see the impact of Le Chatelier's principle on chemical equations, let's try to see what the principle states that when a change is imposed on a system at equilibrium, the equilibrium will shift to counteract the change. I'll repeat. When a change is imposed on a system at equilibrium, the equilibrium will shift to counteract the change. Here you can see there is a reaction. It is between A2 molecule and B2 molecule to give product AB3. And as per the balanced chemical equation, one molecule of A2 will react with 3 molecules of B2 to give 2 molecules of AB3. Now, before seeing how to apply the concept of Le Chatelier's principle in this particular situation, let's see how or what are the factors that can affect the what are the factors that would be affecting the equilibrium of this particular reaction, and what is a reaction at equilibrium is all about. Now, as far as a reaction in equilibrium is concerned, at any point of time it will be having certain amount of reactants and certain amount of products. Do you know why? It is because a reaction in equilibrium will be proceeding in two opposite directions. A certain quantity of the reactants at any point of time will be getting converted to products. Proportionate quantity of the products will be getting converted back to reactants. That is the reason why at any point of time a reaction in equilibrium will be having the reactants as well as the products inside it. Now, as far as the factors concerned, there are several factors that would be affecting the equilibrium. It can be affected by concentration change. It can be affected by the change in pressure, or even it can be affected by the temperature change, because each and every reaction is associated with an enthalpy of reaction. In this situation, we will be seeing how pressure is going to affect the equilibrium and how we will be applying Le Chatelier's principle with respect to pressure variation. So let's assume, let's take the case with system 1. This system, let's assume that it is in equilibrium, meaning it is having A2 molecules, B2 molecules as well as AB3 molecules inside it. And being in an equilibrium condition, the pressure is remaining 2 even after the passage of several minutes or several hours. This pressure is going to remain the same. It is not going to change. So that's why I said that the system 1 is in equilibrium. Now, let's assume that I am changing the pressure. I can change the pressure by the addition of A2 molecules, B2 molecules, AB3 molecules. All of them I can add to change the pressure, or I can go with any one of these also. So now let's assume that I am increasing the pressure of this system to a new value by the addition of, let's assume, A2. By the addition of A2, I am increasing the pressure. Now, the system doesn't want to have a new pressure. It was comfortable with its lower pressure. What the system will do? It will react to the change that has happened to it. Now, how do you think the system will be reacting so that it can get back the equilibrium? For that, let's try to understand the situation based on the balanced chemical equation. As far as the reactants are concerned, there are 4 molecules. How 4? 1 A2 molecule and 3 B2 molecules. Add them up, you will get number 4. But as far as the product is concerned, there are only 2 molecules. So reactant side, there are more molecules, and the product side, there are only lesser molecules. So now just think of a situation. Just think, in which direction do you think this reaction should be changing? In which direction do you think the reaction has to proceed so that it will be undergoing a reduction in pressure? You may pause the video for a while and think of the possible answer. So, which side would be favorable so that the reaction mixture gets a lower pressure? If you said in the forward direction, you are right. The reaction, if it is proceeding in the forward direction only it will be able to reduce the number of particles, because product side has lesser particles, reactant side is having more number of particles. So if the reaction is proceeding in the backward direction, the molecule number will increase, the pressure will increase all the more. So that is never a favorable situation. Only if the reaction is proceeding in the forward direction, it will be able to reduce the pressure. So now let's try to understand the same example in another situation. So again, the same reaction I have taken A2 and B2 giving AB3, but this time I am setting an equilibrium condition with 4 atm pressure. That is the original condition. The original situation is set for 4 atm pressure. The system is at equilibrium, meaning there is certain number of A2 molecules, B2 molecules which are getting converted to the product, and a proportionate quantity of AB3 which is getting converted back to the reactant. Now, let's assume that I am reducing the pressure. How can I do it? I just need to remove few gas molecules from the reaction mixture. The pressure will obviously drop down. But the system doesn't want it. System want a 4 atm pressure condition. So, how do you think this time the system will be responding to the change what I have brought? You may pause the video and think for the possible solution. If you think that the reaction is proceeding in the backward direction, you are right. Because already the system is in a low pressure condition, it wants to increase the pressure. And more number of particles are there in the reactant side. So only if the reaction proceeds in the backward direction towards the reactant side, it will be able to get more number of molecules. So that's Le Chatelier's principle. When a disturbance is given to a system, the system will respond, will react to get back its equilibrium. This is having an application. Now, as far as this particular situation itself is concerned, we came to the conclusion that the reaction is proceeding in the backward direction. Now, just imagine a real life situation. Assume that you are doing a synthesis, and when you're removing the product, when you're trying to remove the gaseous products from the reaction mixture, what if the reaction is proceeding in the backward direction? Do you think it is favorable to increase the yield? So whenever you do an experiment aiming to get high yield, you may apply the concept of Le Chatelier's principle, find out the situations which will help you shift the direction of the reaction in the forward direction towards the product side, so that you can get a good amount of yield. So that's all for now in this particular video.